Hello, videos on section 4.2, which is triangle congruence side, 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 and side angle side. That is what each of those three letters stand for. And the target is to prove two triangles that are congruent using the side, 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 and side angle side postulates. So we're looking at two different triangles, and we're using these theorems or postulates in order to prove that they are congruent to each other. So the first one is side, 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 or I will write 3 S's for short since that's what it stands for. And side, side, side says that if 3 sides of one triangle are congruent to their corresponding 3 sides of another triangle, then they're congruent. So for example, if this side AB is congruent to the DE over here, and then we have BC is congruent to EF, and then for the last one, AC is congruent to DF. Since we have 3 pairs of corresponding congruent sides, that means that the triangle ABC is congruent to the triangle DEF. And notice again the order that I am writing them in, that you go from AB to C to from DEF onto the other one. The order is the exact same with the corresponding sides. AB is the first segment, BC is the second, DE is the first one, EF is the second one. So let's take a look at an example on how we can prove this in a different scenario. So if we have 2 triangles right here, one of them is NPL and the other one is LMN, and we are asked to prove that these 2 triangles are congruent. We already know that PN is congruent to LM based on the information given, and then we also know that PL is congruent to NM. This is information that's already given in the problem based on the markings in the diagram. So another thing that we can look at is, since the 2 triangles share the same side, we know that NL is congruent to NL, since they are the exact same side length. But NL is the missing side of this triangle, and it's also the missing side of this triangle. So depending on what you're looking at it, we have 1 pair, 2 pair, and 3 pairs of congruent sides. So therefore, which are these 3 dots, mean therefore by side, 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 triangle NPL is congruent to triangle LMN. If you choose to write these in a different order, you must also write your second triangle in the exact corresponding order that is appropriate to that one. But since they share the same side, and we already know there's 2 pairs already, the 3rd pair is the missing one, side, 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 the 2 triangles are congruent. Now the other theorem that I want to talk about is side angle side. And side angle side is a bit different, to where you're looking at 2 sides of one triangle and the included angle of the other one. And the included is the big part that always gets a lot of people into trouble, is that they may think it could be any angle in any 2 sides. No, if you look at any 2 sides of a triangle, the angle that is between them. So if you have a triangle that looks like this, and you're looking at these 2 sides right here, the angle between them is the angle that makes up those 2 sides, which is this one. It's not those 2. They do not make up those 2 sides. This is the included angle. Alright, so if you have 2 sides and the included angle of one triangle congruent to 2 sides and the included angle of another one, then that means those 2 triangles are congruent. So for example, down here, if you know that AB is congruent to DE, AC is congruent to DF, and angle A is congruent to angle D, by side, 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 or side angle side, sorry, triangle ABC is congruent to triangle DEF. And again, the exact same order for each of the triangles. So the big part is the included angle is the side angle side. The side is pretty easy, just 3 sides that are congruent are equal to each other. But side angle side is any 2 sides that are congruent, and the included angle means that each of the triangles are congruent. Okay, thank you.